Okay, today we're doing a demonstration talking about designing a drum type oil skimmer in Fusion 360. Video playback speed has been sped up in the interest of saving time. So let's get started. I'm going to start off by bringing in an air motor from McMaster Car. I like to bring in parts, SAT files from their website. That way you don't have to model every nut, bolt, screw, etc. Woo! There's also other online libraries that you can use to bring in parts or components to speed up your iteration design process. So I'm just looking at the specs of this one. So yes, it is available for a SAT file. We'll bring it in, orient it how I want it. Obviously, we want the muffler at 12 o'clock. In the render tab, I'm going to go ahead and paint it just so it pops on the screen more. Like a glossy blue for now. And I'm going to paint the muffler black. Yeah. Go back to design. I think I need to reorientate this air motor. And create a sketch on this face. What I'd like to do is create the actual metal mounting plate that this air motor is going to bolt to. Then we need to leave a circle for the shaft to go through the plate. Just taking a measurement. And create a rectangle using the center point. Pull out my rectangle. And we get 16 inches by 4 inches. And then using the cut tool, I'm going to remove my lines that I don't want. Excuse me. Then we'll say finish sketch, extrude. I'll select the parts we want to extrude, and we want a new body. We want it to be 0.25 inches thick. So there's our mounting plate. There's our mounting holes. You can see they're already pre-threaded. I was thinking I may use countersink screws to mount the air motor to this mounting plate. Just taking a measurement. And then I'll bring in some mounting screws again from McMaster Car. They don't need to be very long. flathead. Do hex drive. Because this will be exposed to water, I prefer them to be made out of stainless steel. See, they offer different sizes, different finishes. That looks good. A little bit longer than what I want. Oh, and that's going to be too big. Let's delete that. The other thing I'm noticing on our mounting plate is I'm thinking there's not going to be quite enough meat or thickness between the edge of the mounting plate and the edge of the mounting bolt head. I'll show you what I mean here in a minute. So for example, even if we try to use this screw, you see how the screw is going to stick out over the edge of that mounting plate? That's no good. So we're going to have to go back into this sketch. See, edit profile sketch. And I'm simply going to add a larger circle to give more material there for the bolt head to tighten against, and then use the cut command to remove those lines and arcs I don't want. Finish sketch. Turn my sketch on, and then say extrude. And this body will delete. Now we can extrude. And again, I want new body, 0.25 inches thick. That looks better. You can see we have more material now for a bolt head to tighten against. And I'm just going to bring in a standard hex bolt. Yeah, that looks better. So we'll see how this looks. Yep. You probably could have grabbed one that's a little bit longer, but for this demonstration, you get the idea. Then we'll grab this one bolt and say create copy, move our copy over, get it aligned where we want it, say OK, and then we'll grab both of those two bolts and say create copy, drag them down to the other two mounting holes, and now our air motor is mounted to our mounting plate. That looks like it'll work just fine. Just taking some measurements now of the drive shaft and the keyway. constructing an offset plane. And then I'm going to create a sketch on that offset plane. And we're going to extrude out our actual drum. So go over to Create Sketch, click on that offset plane. And we obviously need a hub with a socket that will accept the drive shaft. Extrude that out. So you can see that's how we'll connect to our drive shaft. Say new body. Okay. I'll create a sketch on that face. Create a circle. And this will be our actual oleophilic material, the actual drum that will spin slowly on the surface of the water, and the oil will stick to the drum as the drum rotates. And that air motor is what's going to rotate our drum. Like 15 inches long. I think I'm happy with that. And later on, we'll go back and add some reinforcement gussets to that hub, between the hub and the drum. I'm just going to extend that out so we have it poking out the other side. And on the other side, it's just going to be attached to a pellet bearing block. Add some color to it. This could be made out of stainless steel, polypropylene, some sort of plastic that's oleophilic. Continuing on, just taking some measurements. So you can use the extrude or push-pull command to shorten that hub. Say cut. If you see red like that, that means cut. So yeah, I think I'm happy with that. I'm going to create a sketch on this face. And what I'm doing now is creating a shaft that will go through the pellet bearing block, because this is just the idler side, it's not the driven side. I'm simply going to copy this body to create my other mounting plate on the other side. There we go. Create a sketch in a circle. Want to be slightly bigger than the shaft to allow the shaft to go through, and then we want to fill in the larger circle. We'll use the extrude command, and at this point we'll say new body, 0.25, join. There you go. So now we'll bring in our pellet bearing block. Again, ideally made out of stainless steel, sealed bearing. We don't want water getting in. We'll orientate it how we want it. Need to move it in slightly. There we go. Say okay. And then under the render, we're going to paint that pillow bearing block green for now. Make it pop on the screen. I want to chrome plate our shaft and our Allen set screw. Yep. Then we'll bring in 2 mounting bolts to mount the pillow bearing block to that mounting plate. Again, this one doesn't need to be super long. Again, we're going with the socket head, stainless steel. So we'll drag that over, place it where we want it. And obviously we would need to drill and tap that mounting plate if this was going to actually be built. So we'll place our first cap screw. Right about there. Okay. Then we'll simply select that cap screw, say create copy, drag our copy, and now we have our 2 mounting bolts. That'll work. Saving our work as we go. I'm going to create a sketch on this face. Make a rectangle, and we'll extrude this rectangle out. That'll become this cross member that'll be welded to the either side plates. And render, we'll paint it blue. There we go. The other cross member, I want it to be removable. I do not want it to be welded in place. So I'm going to create some mounting plates. And then we need to extrude out a oil collection tank to receive the oil that is going to get squeegeed off of the drum. Extrude that tank out. Yep. Then I'll use a shell command to open it up, and there's our tank.
Woo!
I'll create a sketch on this top face and essentially create a lid for the tank. But then I want an opening in that lid, and that opening is where the oil is going to flow into the tank. Now we'll think about creating our squeegee. And the squeegee will ride on the surface of the drum. So as the drum slowly rotates, the oil will get squeegeed off and flow into our oil collection tank. So the squeegee needs to be at an angle, right about there. Create a sketch on the side of the squeegee so I can create that sharp profile so it better aligns with the drum, because I don't want that large gap, because if the oil hits that curb, it's going to create problems. I want it to be a nice seamless transition between the squeegee and the drum so the oil can flow easily into the tank. And we'll paint it yellow just to make it stand out more. Paint the air motor red. Yeah, I like that. And I want to add a body to the bottom of the collection tank to help facilitate the drainage of the oil down toward the center bottom of the tank. There we go. Thinking about putting a slight bevel on that. Under render, we'll paint the whole thing blue. And I'm going to add a swivel NPT coupler for the outlet on the oil collection tank. So that way, as this thing floats on the surface of the water, that hose can relax and swivel and it doesn't bind up. You can see this one's nice. It has a grease fitting to grease that swivel fitting. Just want to see proper placement. This one is 1.5 inch diameter. We probably could have gone with like 1 inch or 1.25 inch NPT, but that's okay. Extruding out a hole. And we'll paint that swivel fitting red. Yep. Create a sketch on that face, and I want to machine off some of that material that sticks inside the tank. Yeah, that's better. Whoops. So I'll just move it out of the way, machine off the material I don't want. And this side of the fitting would obviously get welded to that oil collection tank. Yep. Just aligning everything up. And we'll create a sketch, make a hole. There we go. Then we'll go back and paint that swivel fitting red. Now we need a pneumatic float switch, and the pneumatic float switch will be attached to the inside of this tank. So as the oil level rises inside the collection tank, the pneumatic float switch will float up and allow air to flow to a pneumatic diaphragm pump that would be mounted on shore or on a barge or a ship. And then once the float switch floats down, it would shut off airflow to that diaphragm pump. This would thread into the side of the collection tank. Paint it red and stainless, chrome. And I want a swivel fitting to mount, a 90-degree swivel fitting to mount to the air inlet on the air motor. And again, using a swivel fitting, so as this unit floats around on the surface of the water, the air supply hose can float around and swivel and pivot and not get kinked or bound up. That's 1/2-inch NPT. Under render, add some color. Yep. And then I want to add an NPT to barb adapter. And that one looks like the barb is a little bit too small for what we need. Yeah, we don't want our suction hose to be too small a diameter. We also don't need it to be too large and heavy and stiff. We still want to maintain good oil flow to our diaphragm pump. That's going to pump the oil out of that collection tank. Then we'll create our suction hose. Paint it black. Then we'll create a sketch on this face and extrude out our air line. Paint it black for now. Then we'll create a shell so you can see that it's a tube or a hose. Then I'll create an offset plane and simply draw 2 lines and an arc. I'll create a fillet or a bevel there, that corner, radius it. Then we'll use a pipe command, say new body. There's our first air hose. And then we need a second air hose to that float switch. I just want to get rid of this center. There we go. I'll extrude it out. Select it, create a copy to make our second air supply line. One is air going in and one is air going out. And again, that's what controls the diaphragm pump that'll pump the oil out of the collection tank. Extrude that out. Okay. And I like to differentiate the air lines as green. Yeah, and then that bearing will be red. Yeah, that looks better. And then we need to add some mounting bolts that actually bolt the oil collection tank to the mounting plates on the side. And then we'll need to think about installing some floats or buoys. I guess floats would be the more appropriate term to mount to this unit to help it float correctly on the surface of the water. So I'm going to create a sketch on the bottom of this rectangular tubing. Say finish sketch, extrude. We can always extrude it more if we need to in the future. I'm just going to put a bevel on these edges. We'll paint it yellow. So there's our first float. So kind of like a pontoon boat. And then I want to add a float to the actual discharge hose because it's so large and heavy. We'll paint that yellow. Move it up a little bit. And yeah, I do want to lower this front float down a little bit, so we'll just extrude this face. Like so. That's pretty much it. You can see the float inside our oil collection tank there. It's a better view. I'm going to create a tangent plane. And I'm going to create a rectangle that we will extrude up and turn into our gussets. We want to be able to add structural integrity or support to those hubs. Then we'll say extrude. We'll pull it up to about where I want it. New body. Okay. Then we'll create a sketch on this face and simply draw a diagonal line across that face to turn it into an actual gusset here in a minute. Then we'll use extrude, cut to remove the material we don't want. Yep. Say OK. And place it where I want it. Under render, we'll paint that white so it all looks like polypropylene or an oleophilic plastic. Now I'm going to create a pattern. So instead of having to 3D model every single gusset on both sides of this drum, I just create the one gusset and then create a pattern of that gusset. It's not quite where I wanted them to be, so I'm going to try something different. So again, we'll go create pattern, pattern on path. We'll select that body. That'll be our path. And drag that arrow and say path direction. There we go. That's better.
Woo!
So there'll be 3 gussets on each side of the drum. Yeah, that looks good. And then we'll select all 3 gussets and say create copy. And then move our copy to the other side. So for example, if this drum was made out of polypropylene or really any plastic, the way I would fabricate this would be with plastic welding. Pretty much it. See the bottom view. Yeah, I think I'm happy with that. I hope this tutorial helps you with your 3D designs. Here's sort of a final view of our finished product. Again, we have our front view, back view. You can see we have our squeegee, our air motor, our pneumatic switch, float switch, our swivel fitting, our floats, pillow bearing block, the main frame, discharge hose, air supply hose for the air motor, air in to the float switch, and of course air out of the float switch. Please like, share, subscribe, leave me a comment, and thanks for watching.